In this first video, we're going to talk about how to represent functions. First, I want to start by just letting you know that recall that a relation, relation is simply, let me write that. A relation is simply an ordered pair, meaning some x value as it relates to some y value. Now, in that, the domain would be all of the x values that we are considering for this relation. And the range would be all of the y values that we are looking at in this relation. So, for example, let's put that right over here. For example, if we were given this first set of a relation of -3, 3, and then the next one would be 0, 7. The next one would be 1, -5, and the last one would be 2, 4. The domain would be equal to -3, 0, 1, and 2. So we just write it just like that. -3, 0, 1, and 2. While the range is going to be the 3, 7, -5, and 4. So the range is equal to 3, 7, -5, and 4. Now this is the simplest way to think about domain and range. Domain is all of the x values, range is all of the y values. Domain is all of the x values, while the range is all of the y values for what we're looking at. Okay? Now the next thing that we can look at and consider in this kind of a question is where these different relations are located and what quadrant they are. So if we take a point like this, and I'm going to first look at this first point, this -3, 3. -3 would be over in 1, 2, 3, -3, up 1, 2, 3. So so that point is right over here. And that would be in that's the first quadrant, second quadrant, third quadrant, and fourth quadrant. So this first point is in the second quadrant. Okay? Now, a relation can also be represented in a table by mapping. This mapping is going to illustrate how each element of the domain and range, that's each element or each part of the problem we're looking at, is paired within that range. So I've already mapped this first one, and the next one I'm going to do is this 0, 7. So if I take 0, that's 0, and then I have to go up 7. 1, 2, 3, 4, 5, 6, 7. So now I'm up here. The third point is 1, -5. 1, 1, 2, 3, 4, 5. So it's 1, -5 way down here. And the fourth point is 2, 4. So I go 1, 2, and then I go 1, 2, 3, 4. So I went over to 1, 2, up 2, 3, 4. So my point is going to be right in here. Now, all of these pieces together would create what we call a function, because each point, each x, goes with a y. That's what functions are. It's a relation. It's how one part exists and relates to another part. And this is a function because it also passes what's called the vertical line test, which means there is no point when I could draw a vertical line and it would pass more than one of these points. Okay, remember the vertical line test. Okay, so with all of that in mind, We now want to show a different way to map, and this is the last thing that we really need to show here. I could draw sort of a domain and range sort of map like this. And I could say that a 2, 3, and a 4 are going to map over to a 1, 3, 7. So what that means is that I'm telling you, just like up here in this purple problem, the domain is 3012, which was 3012. Now what I'm saying in this orange problem is the domain, I'm just writing it differently, the same exact relation. A domain, if it's a 2, well, that means the 2 goes with a 1. The 3 goes with a 3. The 4 goes with the 7. So it actually coordinates out to the exact same points. Well, not say it. The points are going to be, if we write it like that, it'd be 2, 1. It would be 3, 3. It would be 4, 7. And of course, we can graph all of those. The first one would be 1, 2, up 1. The second would be 1, 2 over 3, up 3. The third one would be over 4 and up 7. So we're now up here. So now you get a sense that we are building a relation that is increasing. As the x value increases, the y value increases, and we sort of almost start seeing a linear type relation. Now we're not going to call it a linear relation because we only have points. And we have not defined what happens in between these spots, where a linear would imply that everything along the way is actually filled in. But right now, we're simply talking about points. So this would also pass the vertical line test in that each point, as every vertical line would only go through one relation or one part of the function. So this is a function also. Okay, so I hope that that helps. Some stuff that I would like to practice with. Here are some, for the first example, question is, state the domain and range of these points. 2, 7, 3, 10, 1, 6. So that's the first. What is the domain and range, and is it a function? The second question, we're going to do it like this. X and Y in a table. So here's the second question. 1, 5, 2, 7, and 1, 9. So is this one a function, and what is the domain and range? And lastly, I'm going to do a third question, which is going to be of this format. Well, this really isn't lastly. Third question is going to be the domain and the range. And we'll do this rectangular box map idea. So if you see it, you'll recognize it. And here we have a 3 maps over to a 2, and a -1 also maps to a 2. 0 maps to a -3, and -2 maps over to a -2. So again, the question's the same on all of these. What is the domain? What is the range? And is it a function? Make sure you pause and try to answer that for all 3 of these questions. The next thing I would like you to try is looking at a picture and identify the quadrants that these points are in. The orange points and the blue points and the red points So what quadrants are they in? The first, second, third, or fourth quadrant, and are the orange ones a function? Are the red ones a function? And are the blue ones a function? And lastly, the last thing I'd like you to do is sketch these points. Let me draw a little line. Sketch 5, 3. Sketch 8, negative 6. What quadrant are both of those in? What quadrant is 5, 3 in, and what quadrant is 8, negative 6 in? Okay, I hope this helps. If you have questions about representing functions, please ask.